Hey guys, welcome back to another video. In today's video guys, we are going to be having a look at the February-March 2018 paper 2 for chemistry, and again I'm going to be trying my best to upload as many MCQ questions because the MCQ May-June paper is coming close, so I'll try my best to upload as much as I can. So here today we are going to be having a look at the February-March 2018 45 minutes as you can see here, and this is 0620, okay, which is the extended. Okay, so we move on to the first question. The first question seems like it's always usually on diffusion or sometimes just simple experiments involving the apparatus and so on and so forth. But here we have a famous experiment which is testing on diffusion, which involves hydrochloric acid, HCl gas, and we have ammonia gas, and they are kept into this following apparatus on two ends with a bung on each side, and then there's a solid that's formed right here. Okay, there's a solid that's formed here away from the ammonia gas but closer to the hydrogen chloride gas. So let's see here. It says the experiment is repeated using hydrogen bromide. So hydrogen bromide, which is here. Now I am supposing hydrogen bromide is more heavier, but we'll see. It says how far along does the tube does the solid ammonium bromide form. Now remember, for any gas in diffusion we have two factors. The first one is temperature, and the second factor is the mass of the gas. These two factors affect diffusion. Okay, they affect diffusion. Okay, so they affect diffusion. Okay, so in this case, if we are replacing hydrogen chloride, okay, the mass of hydrogen chloride right here, um, the mass of hydrogen chloride would be 1 plus chlorine, and if we go to the periodic table, you know that chlorine is 35.5. You can see chlorine right here is 35.5, so 1 plus 35.5, which is 36.5. That is a mass. But now hydrogen bromide, hydrogen would be 1 plus bromine. Bromine here, you can see bromine, where is bromine? Here it's 80. So bromine is more heavier. So 1 plus 80, which is 81. If it is more heavier, right, and if before the hydrogen chloride and ammonia gas form here, if it's more heavy, then the hydrogen bromide gas will diffuse slower. If it diffuses slower, that simply means that when the ammonia gas will diffuse at the same rate, but this time it will form at this, because it will form at this point, because it's more heavier. Okay, so that's the reason to why it would form at this region. Okay, so that is the reason why it would form at that reason, hence why the answer for this one would be A. Okay, so this was quite straightforward. You look at the mass of the two, and because it's more heavier, it will diffuse slower. Okay, so we move on to the next question now. The next question says substance L melts at -7 degrees and is a brown liquid at room temperature. So it is a liquid, okay, at room temperature. It says which temperature is the boiling point of pure L. Okay, now let's use the elimination technique to get the answers to remove. Okay, so first of all, it can't be -77 degrees because it is less than the melting point, which is not possible, right? This much, -77 degrees, not possible. Okay, because the melting point is -7 degrees, so the boiling point cannot be -77 degrees. Then again, here it can't be this because this is the melting point. We have to look for the boiling point, not the melting point, so it can't have the same melting point and boiling point. Now we have two possibilities. It could be 59 degrees or it could be 107 degrees. But again, look at this. Because it's a brown liquid at room temperature, this much will be too high. 117 degrees would be too high. The difference between this would be too high for a liquid which is a brown liquid, and I believe we have only like around two liquids in the periodic table that we know, which is mercury and bromine. So in this case it will be bromine, and we know the boiling point of that is 59 degrees because we all can do fractional distillation on that. So the answer for number 2 is C. You need to think a bit here because This would be a tricky question. Someone would pick C, someone would pick D, but here the case would be C because of the bromine, liquid. Okay, we move on to question 3 now. These are quite some straightforward questions. We move on to a chromatography question, and here it says chromatography is done on a mixture containing a drug. The RF value is 0.66. RF value is simply, if I write this, so for example, then we'll explain it later. Okay, let's just read the question first. It says the diagram is not drawn to scale. Which spot on the chromatogram represents a drug? Okay, so let's see. Now the RF value, is 0.66. This simply means that this is the distance traveled by the dye, over the entire distance between the solvent front to the baseline, which is 15 centimeters here. So in this case, we would use our calculator, and here you would say, for example, I think B might be the answer, because 9.9 divided by 15 is equals to what? So here you would use your calculator, and then you would find out whether it is equal to 0.66. So let me use my calculator and see what it gives me. So yeah, if I use my calculator, you do 9.9 divided by 15, you will get exactly 0.66, and hence why that will make die B the answer to this, because it is the distance traveled by the die over the entire distance from the baseline to the solvent front. So the answer is B in this question. We move on to the next question, number 4. It says cesium is an element in group 1 of the periodic table. When cesium reacts, it forms a positive ion because it loses an electron, hence why it forms a positive ion. How is a cesium ion formed? Okay, exactly, just explained it. It will lose an electron, right? Because it loses an electron, that is the reason why it has a positive ion. Actually, any metal or any group 1 metal, group 2 metal, if it loses the electron to become an octet state, right, then it will have a positive ion. But if it gains, it will have a negative ion. For example, if oxygen, which is in group 6, it is in group 6, if this one becomes an ion, it will have a charge of 2 negative, because it gains 2 electrons to become an octet state, because right now the electronic configuration of oxygen is 2,6. So to become an octet state simply means the outer shell has 8 electrons. Okay, that's the meaning of outer shell electrons. For group 1 it would be 281. So losing this 1 electron will make it go to the octet state. Okay, so that means it will have a positive ion. Okay, that's the main reason why we could either have a positive ion or a negative ion depending on the electron. Moving to the next question, it says the structure of copper is described as a lattice of positive ions in a sea of electrons. A sea of electrons simply mean they can move around, and here it is a positive ion, which I just explained in the previous one. Because copper is a metal, it will lose electrons, hence why forming a positive ion. It says which statements are correct. Okay, let's have a look at this. Copper, remember, is a good conductor of electricity. Maybe we might not need it in the question, but you always need to know in chemistry, copper is a good conductor of electricity. Many times that is the reason they ask you, why is copper a good conductor of electricity? This is because it has the sea of electrons, because it can carry charge, carry current. Okay, we move on. So it says copper has a high melting point because of the strong electrostatic attraction between the positive ions and the sea of electrons. That is true, that is correct. Now, because it has a high melting point, because of the strong force between these ions and the sea of electrons, so this one is right, correct. Copper is malleable because the layers of atoms can slide past each other. That is again correct. Whenever we talk about malleable, we always talk about the layers sliding past each other, so that is correct. Copper atoms can be oxidized to form copper ions by losing electrons. So what here you remember is oil rig. So when it is oxidation, it is a loss of electrons, and hence why this is correct. So the answer is A, quite straightforward. All of them are correct. Okay, we move on to the next question. Okay, question 6. 3 statements about diamond, graphite, and silicon are listed. So again, these are all macromolecular structures. You need to know each of the differences between diamond, graphite, silicons, and the similarities between diamond and silicon, which they are similar in terms of structure. But let's have a look at this question. Okay. So here it says diamond and graphite both have giant covalent structures. Do they have giant covalent structures? Yeah, that's true. We just said it, they're giant macromolecular structures, so that is correct. And they all have covalent bonds, so that's something that you need to know. Let's say it says silicon 4 oxide. Silicon and oxygen atoms are joined together by covalent bonds throughout the whole structure. Yep. If this is correct, then of course, they all are covalent bonds throughout the whole structure. Diamond and silicon have both similar structures. That is correct. Answer is 1, 2, and 3, which is A right here. Okay, move on to the next question. We did a video on talking about stoichiometry, so if you're having problems with stoichiometry, go and check that video out. It will be quite helpful. So here we have a stoichiometry question. It says the concentration of hydrochloric acid is 0.5 moles per dm cubed. How many moles of dm cubed are present in this? So we know the formula. The formula says moles equals to the concentration times the volume, and this will be in dm cubed. So I'm going to use my calculator. So 0.5 times 25 over 1000, which will give me 0.0125, which is A right here. So 7 is A. Move on to the next question. It says a sample of iron oxide contains 50.4 grams of iron and 21.6 grams of oxygen. So here is empirical formula. So we divide by iron. If we go to the periodic table, we can see where is iron. Iron is here, so it says 56. So we divide by 56 and 21. So right now we're just dividing by the RAM. So 21 divided by 16. So let's use our calculator again here. So 50.4 divided by 56 will give us 0.9. So we'll write 0.9, and then 21.6 divided by 16 is going to give us 1.35. So we're going to divide each by 1.35 divided by 0.9 is actually 1.5. Now I'm going to multiply both sides by 2 to get me a whole number. So it'll become 2 and 3. So the answer will be Fe2O3. So the answer for number 8 is C right here, Fe2O3. Move on to number 9. It says a solution of copper to sulfate can be electrolyzed using copper electrodes and carbon electrodes. We can also use graphite electrodes. Actually, this is copper to sulfate. Okay, but like usually electrodes are made up of carbon and graphite because of the inert nature they have, and also they conduct electricity. So it says which statements are correct. Using copper electrodes, oxygen gas forms at the anode. Okay, now oxygen gas. When we have copper sulfate, when we electrolyze copper sulfate, what happens when this does not form? This does not form. Okay, at the anode, oxygen is not formed, but using copper electrodes, copper atoms lose electrons at anode. Yeah, this is correct. Losing electrons at anode is correct. Okay, and then let's see, using carbon electrodes, copper metal forms at the cathode. That is correct. Using carbon electrodes, that's just a normal electrolysis. At the cathode, it's always the metal or hydrogen gas. So but here it's because it's a solution of copper sulfate, then it will be copper. Using copper electrode, copper ions gain electrons at the cathode. Now yep, they will gain electrons because it is a reduction. So the answer will be 2, 3, 4, which is C. Okay, so that is the answer for number 9. Move on to the next question. Okay, so let's look at this question. It says pairs of metals are connected together to make a simple cell as shown. Okay, and we have a voltmeter, we have metal 1, metal 2, and then we have the electrolyte. It says the table shows the reading on the voltmeter when different metals are used. So we have different metals. For example, we have beryllium, then there's 0 volts. If we have beryllium, then cerium, then is a 0.64 volts. Okay, so it says that. It says if metal 2 is more reactive than metal 1, then it's positive. So if metal 2 is more reactive than metal 1, then it is positive. So in this case, cerium is more reactive than beryllium. We can get to know that because it's a positive voltage. It says the greater the difference in the reactivity of the metals, the larger the reading on the voltmeter. So the greater the difference. So for example, the highest, if it's 0.9 voltage, meaning manganese and cobalt will have a big difference between themselves in terms of reactivity. Okay, so now let's look at which one is the most reactive, which one is the least reactive. Now, what we can do again, use the elimination method. Let's see which one is more reactive. Is it cerium or is it cobalt? Let's have a look at that first. Okay, so if we go to the ones here, it says cerium and we have cobalt when they react with beryllium. Which one is more reactive? One is a positive, one is a negative. It will be the positive value because it says the voltage measured in positive is more reactive. So the more reactive element, first of all, is cerium. So that is the most reactive element as of now. Okay, so that's the most reactive element. Okay, so yeah, that is the most reactive. So it's the between these two. Okay, then is beryllium more reactive? Yeah, so it has, okay, now we need to look at between cobalt and manganese, which one is more reactive. So let's have a look at this one. So we have cobalt and we have manganese. So we go to this range here, sorry, we go to the third row, and you can see it's a positive value. If it's a positive value, meaning manganese is more reactive. So if manganese is more reactive, the answer will be B. Okay, so just follow the instructions and it was a quite simple question. So the answer is B, and we don't need to go to the last column because we already know the answer. Okay, we go to number 11. It says the energy level diagram for the reaction between X2 and Y2 form a gas as shown, which is XY, to form XY gas as shown. Okay, which statement is correct? So here it is going down, so this is an exothermic reaction. Okay, because it is going down, the energy is going down. That's how I simply remember it. Okay, so here let's see, energy is released when X2 and Y2 bonds are broken. That is wrong. Energy is not released, or is it? No, when bonds are broken, that's wrong. Okay, because it's an exothermic reaction, hence why this is wrong. Okay, so it's when bonds are formed is when energy is released, not when broken. Energy is needed to form XY bonds. That is wrong. That is endothermic. Energy is not taken in, hence why you do not need that. The energy change for the reaction is negative. That is correct. Anytime it is exothermic, the change is negative. Usually even in paper 4, after they give you the equation on the side, they say it's negative. That means it is an exothermic reaction, meaning forward reaction is exothermic. So the answer is C. We move on to the next question. Okay, it says methane burns in oxygen to form carbon dioxide and water. It says the bond energies are shown in the table. Okay, so let's see. So first of all, what I usually like to do is I split this equation. So let's start off with splitting these two equations. So CH4 is written like this, CH4, and you can see it contains CH, 4 of them. So it contains 4 of 4 times 10, which is equals to, if I use my calculator, 4 times 4, 10 is equals to 1640. Then you can see here 2O2, meaning 2 OO bonds. Okay, so OO bonds is 496, so 496 times 2 is 992. So if I add those two together, I will get 2632. So here I will write 2632. Now we do the other side of it. So let me quickly rub this. And we do the other side. Okay, so the other side we have CO2. How do you write CO2? It is like this. That is how you write CO2. It's comprised of CO, which is both like that. So CO and then CO. So 805 times 2 will give us that. So 805 times 2 will give us 1610. And then we have 2H2O. So which will be what? So how do you write 2H2O? It will be 2H, I believe 2H2O. Okay, give me a second. So how can we write 2H2O? Okay, how can we write 2H2O? Will it be just 2H like this? Not possible, right? Because it can't be like that, but it's 2H2O. So to write 2H2O, okay, to write 2H2O, you simply have to, okay, so you simply have to do this, and then actually it's like, let me do it again. It will be like this. Okay, so OH, which is this 460. So 2 times 460. Actually, 1 second. We'll have one bond here. We'll have another bond here. So 460 times 2 will give us 920, and then 920 times 2 will be 1840. So now I add these two together. and I will get 345. So 3450. Now I do this minus this, so it will be 2632 minus 3450. It will give us minus 18. It will give us minus 818, which is A right here. So this one, quite straightforward again. Yeah, so let us move on to the next question. Okay, so we move on to number 13. Number 13 says methanol is made by reacting carbon monoxide with hydrogen. The reaction is reversible. The forward reaction is exothermic, so forward reaction is exothermic. It says which combination of temperatures and pressure gives the highest equilibrium yield of ethanol. So let's see. Because it's forward, meaning we need less temperature. Oh wait, we need what? Methanol, yeah. So we need less temperature. And the mole ratio is 3:1, so we need more pressure. Okay, so less temperature, more pressure. Let's see, we're looking at something like that. Okay. Okay, so the answer could be either this two, and because we need more atmospheric pressure, meaning B would be the correct answer. Okay, we move on to the next question. Number 14 says the ionic equation for the reaction between zinc and aqueous copper ions are shown. Which statement about this reaction is correct? Okay, let's see. Copper ions are oxidized and their oxidation state changes. Copper ions are reduced. Okay, so let's see what's happening here. Zinc in this case. Zinc is getting 2 plus, becoming an ion, right? And copper is losing. Okay. So what happens here? What happens here is this zinc atom is getting oxidized. Okay, it's getting oxidized, and the copper is getting reduced. Okay, and the oxidation state changes. So we're looking at something where zinc is getting oxidized, or we could say copper is getting reduced. Copper is getting reduced, and when the oxidation happens, the oxidation state changes. So let's see, copper ions are oxidized. No, copper ions are reduced, so this is wrong. Copper ions are reduced, that is correct, but they do not lose electrons, so that's wrong. It's the state that changes. Zinc atoms are oxidized and their oxidation state changes, so that is the correct answer. In which reaction is the rate of reaction not affected by light? Okay, so we're looking at something related to UV light, and we know many equations that involve UV light. So let's see. The conversion of carbon dioxide in water to glucose and oxygen in green plants. This is what? Photosynthesis, isn't it? And we need light in that, so this is wrong. The reaction of bromine and ethene. Yeah, this one is the one. This one is a substitution reaction. In a substitution reaction, we do not need, or is this an addition reaction? Okay, it's one of them, right? So chlorine and methane, this one is UV light, we need it. Okay, this one we will need it. This one we will need it. So actually bromine and ethene is an addition reaction. This one is a substitution, hence why it needs UV light. And a reduction of silver ions to silver again will need UV light. So the answer is B. Okay, so we move on to the next question. It says calcium carbonate reacts with dilute hydrochloric acid to form bubbles of carbon dioxide. At a higher temperature, the same reaction is faster, which Rowe explains this observation. Okay, so let's see. It says when this carbonate reacts with dilute hydrochloric acid, it starts bubbling. At a higher temperature, it's faster. Why is it faster? It can't stay the same. The collision rate increases, and the number of molecules with sufficient energy to react will be, of course, more. Hence why there is a faster rate of reaction. Quite straightforward. Move on. Ethanoic acid. Remember, acids are proton donors, so remember that, and then bases are proton acceptors. It says ethanoic acid reacts with water to produce an acidic solution, which Rowe describes the roles of ethanoic acid and water in the reaction. So ethanoic acid is a proton donor, so it's within, the answer should be C or D. And water is a base. Okay, water is a base, so it will accept a proton. So the answer is C. Quite straightforward again. Some straightforward questions now. A solution of compound Z gives a light blue precipitate with aqueous ammonia. The precipitate dissolves in an excess of ammonia. A flame test is done on compound Z. Okay, so this is first of all a light blue precipitate. That means it could be copper. Instantly I could know it could be copper. But again, it said with aqueous ammonia. But anytime usually you mention copper or light blue, it's usually that. So flame test of copper will be blue-green. Okay. Okay, so that's straightforward again. Anytime usually in these MCQs where they mention blue, it's usually always dealing with copper. Carbon, copper, magnesium, sodium, sulfur can all form oxides. How many of these elements are acidic oxides? Acidic oxides. Okay, what forms an acidic oxide? Okay, what forms an acidic oxide? Sodium, no. Magnesium, no. Sulfur, yes. Copper, no. Carbon, yes. Because these are non-metals, they form acidic oxide, sorry. Hence why it is how many? 2? Yeah, 2. So 2 is there. Okay, these ones, copper, magnesium, sodium, they all form as basic oxides. Okay, so 19 is B. Which method is used to make salt, copper to sulfate? This one we know from, this copper to sulfate is a very popular experiment. You will need dilute, you need a type of dilute acid, could be hydrochloric acid, and you will need a carbonate. So that's the answer here, carbonate. Okay. Move on to the next question. The periodic table lists all the known elements. Elements are arranged in order of, is it the nucleon number? Is it the proton number? Okay, it is the proton number or the electron number. Okay, the melting points of group 1 elements, the melting points, so anything for group 1, usually the melting points decrease. Right? The melting points decrease as you go down the group. And the melting points of group 7, okay, now I think it should be increased because the answer is C, but it should be increased. And remember, in group 7, the most reactive is on top. Okay, sometimes some people get confused with that. Okay, we move on. So fluorine is more reactive. Okay, so metal X reacts with non-metal Y to form an ionic compound. Ionic compound is non-metal, okay, plus a metal. That's ionic compound. With this formula, what this means, if it's X to Y, that means Y has a valency of 2 and then X has a valency of 1 because they switch. So if it's X, Y, it will be this, and then they switch to form X to Y. Okay, so we're looking for something like this. Now if it's a valency of 2, it could be in either group 2 or group 6. Okay, this is for Y. And for X, if it's a valency of 1, it is either in group 1 or in group 7. Okay, so we're looking at that. Let's see, X is in group 1. Okay, we said it could be in group 1 of the periodic table. That could be correct. Okay, X is in group 2. That is wrong. Okay, Y is in group 7. No, sorry, Y is in what? What's this? No, group 5? No. Okay, Y is not in group 5. Wait, actually it could be. It could be. Okay, sorry, this is group 6, right? Yeah. Okay, sorry, not group 5. Yeah, this is group 6, so that's correct. And then Y is in group 7. No, this is wrong. So the answer is 1 and 3. Sorry, yeah, this is not group 5, this is group 6. Sorry, I read that wrong. So yeah, group 6. Sometimes these Roman numericals are confusing. So IV is 4, V is 5, VI is 6. Yeah, okay. Sometimes I get confused myself. Yeah, so IV is 4, V is 5, VI is 6. Okay. Move on to the next question. It says, which statements about group 1 and group 7 elements are correct? Group 1, group 7. Okay. They usually like testing on halogens and group 1 elements, sometimes even noble gases. So you need to know that, or sometimes even transition metals. You need to know the difference between transition metals and group 1. So it says in group 1, lithium is more reactive than potassium. That's wrong. Potassium is more reactive than lithium. As you go down the group, the reactivity increases. In group 7, chlorine is more reactive than fluorine. Again, that is wrong. I said fluorine is the more reactive than chlorine. So both statements are wrong. The answer is D. Okay, here it says which two properties are physical properties of all pure metals. Remember, here it says all pure metals. Are they all brittle? That's wrong. Okay, they could be brittle, but they're usually good conductors of heat. So that's wrong. They are good conductors of electricity and they are malleable. Yeah, this looks like a good answer. Good conductor of heat, that is correct. Low melting point, that is wrong. They have high melting points. We both know that they have high melting points. Malleable, that's correct. Low densities, that's wrong. Now it can depending, but transition metals have a high density. Okay, so that is wrong. Even group 1 have high density. Okay, aluminium is extracted from aluminium oxide with electrolysis. Al2O3 is what aluminium oxide is. Carbon dioxide is formed in the process. Which equation shows the formation of carbon dioxide during the extraction of aluminium? Okay, So we know Al2O3 could react. Now, okay, with electrolysis, remember this is not blast furnace. This is electrolysis. So this is wrong, and all this is wrong except this, because oxygen is going to be formed at the anode, okay, and because the electrodes are carbon, right, it reacts with the oxygen that is formed to form CO2. That's the reason why it's the answer C. So all the other ones is unnecessary. A sample of solid X. Okay, so question 26, a sample of solid X was added to 3 different solutions to predict the position of X in the reactivity series. Okay, so we have all this. Which other solution would react with solid X? Okay, so when we react it with iron sulfate, there is no reaction. So when we are reacting it with iron sulfate, there is no reaction. But when we react with hydrochloric acid, there is a reaction. Okay, but when we react it with zinc nitrate, so when we react it with nitrates, again there is no reaction. Okay, so what does that tell us? Which other solution would react with solid X? Okay, let's see. Start off with copper sulfate. Will copper sulfate react? It's a sulfate, so no. Calcium sulfate, no. Okay, because calcium, I think if you go to the reactivity series, it's quite low. But copper, it could be actually. Copper could be the answer. Yeah, I think it's copper. Magnesium sulfate, no, it's more reactive. Sodium, no, it's more reactive. So answer is copper. Right? So here you just look at the reactivity series, okay, and you go down, you can see if iron is not there, then something lower than iron's reactivity, it will react. Okay, hence why. Nothing related to sulfates or nitrates, it's all about reactivity. Which statement about the uses of aluminium? Usually for IGCSE, aluminium is used as aircraft bodies, so you need to know that. Copper for wires, iron just for, car bodies or something like that. Let's see, aluminium is used for aircraft manufacture because of its high density. Is it because of the high density? No, it's because of the low density. Okay, we need to have a material to be low dense. Okay, aluminium is used for food containers because it's a good conductor of electricity. No, it is a good food container, but it's not because of good conductor of electricity. It is because of the reason to why it resists corrosion or something like that, and also because it's just it's used mainly for food containers. Okay, the next one, it says copper is used for cooking utensils because it's a good conductor of heat. Yeah, that could be the answer. Yeah, should be the answer. We need it to be a good conductor of heat. That's why we use it for cooking utensils. Stainless steel is used for car bodies because it corrodes easily. No. Actually, it's bad if it corrodes easily, so that's wrong. Number 28. Air is a mixture of gases. We know that air is a mixture of gases comprised of many other stuff. The melting point and boiling points of some gases present in clean dry air are shown in the fractional distillation of liquid air. Which gas boils first? Okay, so in fractional distillation we look at boiling points, so we're just looking at this type of stuff. So which one is the lowest? It will be negative 196, because it will first be 153 as the highest, then negative 183, then negative 186, then negative 196 to be the highest. So this one, answer is C. 28C. Okay, because this one will boil first because of the boiling point. We don't look at anything else but the boiling point. Water must be purified before it is suitable for use in the home. Which processes are used to remove solid impurities? Now, for anything related to water, for purification, okay, remember this, guys. For purification, we first start with filtration and then we move on to chlorination. The stage is always like that. It's always like that. So filtration and chlorination. Answer is C. Which processes do not produce carbon dioxide? Heating limestone, calcium carbonate. We're heating it. Does it form? Does not produce carbon dioxide. This produces. Burning gasoline in car, it does produce. Photosynthesis. Carbon dioxide is a reactant. It's not a product. So this is correct. So production of nylon, again, so I think it should be 3 and 4, which is there's no carbon dioxide produced. Okay, which pair of compounds would make a NPK? NPK is nitrogen, phosphorus, and potassium. So we're looking at that. Anything related to that, let's see. Okay, NPK fertilizer. or we could also use calcium. Okay, but let's see. Let's see. So ammonium, yeah, we can use ammonium for a fertilizer. We can use sulfate for a fertilizer. We can use potassium, and we can use phosphate. So that looks like a good one actually. 31 looks like correct because we don't use hydroxide in this case. We don't use calcium in this case. So yeah, this should be the answer. Okay. For NPK fertilizers, that's all you need to know. Ammonium sulfate, we use it. Potassium phosphate, we use it. Which pollutant gas is produced by the decomposition of vegetation? We all should know this before even. It's always methane. That is one of the source of methane. Okay, the equation for the formation of sulfur trioxide from sulfur dioxide is shown. So this is looks like it's contact process. It's telling us forward reaction is exo. Which combination of pressure and temperature gives us highest for sulfur trioxide? So sulfur trioxide is this. So meaning we need less temperature. Okay, and the mole ratio is 3:2, so more pressure. So the pressure should be high, temperature should be low. Answer is B. Very easy question. Move on to the next question. The diagram shows the pH values of soil in two parts of a garden, X and Y. Lime is used to neutralize the soil in one part of the garden. To which part of the garden should lime? Now, lime is to reduce the acidity. So we should reduce the acidity of Y. So we use Y, and because lime is basic, it can neutralize it. So hence Y. For question 34, it is a D. Right, so for question 24 is D. Remember, if it's basic and it is acidic, this is a neutralization reaction and it will neutralize each other. So hence why we use lime, because it is basic in nature. So we are using it in the part of garden where it's acidic, so we can neutralize the plants, because we should not have acidic plants. Okay, state 1, hydrogen is used as a fuel. That is correct. When hydrogen burns in the air to form water, heat energy is produced. Is that correct or not? Okay, even this is correct. Both of them are correct. So let's see which is correct. Both statements are correct, and statement 2 explains statement 1. So statement 2 explains statement 1. So heat energy is produced. This is a fuel. So yeah, this should be correct. Which you identify compounds in the same homologous series? Same homologous series, they have similar chemical properties because of this same functional group. Now, a functional group is because of the similar chemical properties. Move on to number 37. 3 chemical reactions are shown. Okay, catalytic. Okay, so it says, in which of these reactions does a RAM or RMM of carbon containing compound decrease? Okay, so which one would decrease? So catalytic addition of steam to ethene, that's no. Okay, of a carbon containing compound, decrease. So where is carbon decreasing? Combustion of ethanol, yeah. Fermentation, yeah. So 2 and 3. How is ethanol produced by fermentation? Ethanol is produced through the help of anaerobic respiration, and the temperature should be, I think, 37 degrees, which is close to 30 degrees, so we say 30 degrees. Which substances react together to form ethyl propanate? So we need ethanol and propanoic acid. Okay, so ethyl, this first part is for the alcohol, this is for the acid, so we are looking for ethanol and propanoic acid, which is D. So 39 is D. We go to the last question. It says the structure of chlorofluorocarbon polymer is shown. Which monomer is used to make this? So we look at the one that's repeating, and you can see this part is repeating. It's repeating, this part repeating, this part then repeating, right? So this is the repeating part. Okay, then we identify which one is repeating, and you can see, let's see, it doesn't matter if if it's like CH3 is down here and H is here, as long as it's like this. So I think B is correct. So it doesn't matter if CH3 is down or up here, it just doesn't matter. It's still a monomer and it's still correct. Okay, so that marks the end of today's paper. Hopefully this was helpful for your MCQs and your preparation. I'll try to upload as many as I can. So with that being said, thank you guys for watching this video, and I will see you in the next video. Goodbye.